Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So we've just got to know some vocab. Faces are where you could lay your hand flat on a shape. Then you've got edges where you can run your finger along. And then vertices are the corners, the bits that you would stab into your finger. So we've got 1, 2, 3, 4, 5 on the front, 6, 7, 8, 9, 10, including the back ones. For us to create the smallest number, we need to pick the smallest digits at the start of the number. So the smallest digit is 3, then the next smallest digit is 4, next smallest digit is 5, then the next smallest digit is 8. But it wants it to be an odd number, and this is an even number. So we have to move that 8 forward 1 and have that 5 at the end. So the smallest odd number is 3,485. So 55% is the same as 55 over 100. And what I can do is I can divide top one of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. To find the midpoint, we can use this simple formula. And we're going to start off by finding the midpoint for the x component. And the formula is just adding the two x coordinates and dividing by 2. So we're just going to add the two x coordinates together. So we've got 2 plus minus 1 divided by 2. And that's going to be 1/2, or 0.5. We'll do the same thing for the y coordinates. And the formula is the same, but just with adding the y coordinates together and dividing by 2. So it's going to be -5 plus 2. All of that divided by 2. So that's going to be -3 over 2, or -1.5. To get from the length of a square to the area, we square the length. To work backwards, what we do is we square root, because the inverse of square is square root. So we've got 196 and we're going to square root it to find the length. So we work out the square root of 196, which is what number times itself is 196. And you should learn them from 1 to 15, so you should know all of the square numbers from 1 to 15. So you should know that the answer is 14. So the length therefore is 14. So to work out what the perimeter is going to be the distance around the square. So if I draw a square out, we know that each of these lengths are 14. So it's just going to be 14 times 4, which will be 56. We're going to start off by finding what the multiplier will be. So we'll start off with 100%, and it's a decrease of 32.6%. So we're going to take that away, and that will leave the percentage as 67.4%. Next we need to convert that into a decimal. So we're going to divide it by 100, and that will make it into a multiplier. And the beauty about a multiplier is all we need to do is get the amount from the question, 486, and times it by the multiplier, and it will do all the hard work for us, and it will give us the answer of 327.56. So to draw a line of best fit, you want to make sure that roughly there's the same amount of data on top of your line and below your line. But if you think about it, this line here would work according to that rule. Clearly the line of best fit needs to go with the data. So I'm going to start it roughly here and then just draw a line going down like that. Now you might notice that sometimes like say if I draw that, you might notice that we've got 1, 2, 2 below, maybe this one as well, 3 below, and then 1 on top. Don't worry too much if there's not a complete equal amount on top or below. What we mean is if it looks like that, that's clearly wrong because you've got all of the data below and obviously this one here. You want it roughly so that there's equal amounts at the top and bottom. But if you have it slightly off, so slightly down here or something, don't rub it out. Chances are you'll get the mark. They're quite lenient when you draw lines of best fit. So we've got to first of all work out how many parts there are altogether. So oil has 21 parts, vinegar has 5, so altogether there's 21 plus 5, which is 26 parts. Now how many of those parts are vinegar? Well, vinegar is the second one, so it's going to be this 5. So vinegar has 5 out of the 26 parts, or a fraction would be 5 over 26. For each of these options, try and construct in your head the triangles that would be made from these lengths. And I'm going to give an example for question D, or for option D. And I'm going to construct my triangle just with sticks. So we're going to start off with our first stick, which is 19 centimeters. Then we're going to do another stick, which is going to be 37 centimeters. And we've got one last stick, which is 61 centimeters. Now, looking at the first two sticks, the actual combined distance of them, so when we add them together, so be 19 centimeters plus 37 centimeters, is 56 centimeters. So that's the combined width of them. And you can see that that actually wouldn't be able to create a triangle if the third stick is 61 centimeters. So the side here could combine with this side. So we could move this whole stick here onto this side here, but we can't actually make a triangle with it because the two lengths that we've got won't ever reach the end bit here. They just won't ever reach that bit to be able to create the triangle. And I'm just going to put that back. So our answer is option D. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. To find average speed, we do the total distance and we divide it by the total time.
Now, in this question, we've got a bit of an issue because the question wants kilometres per hour, but the units are given to us in metres and minutes. So we just need to do some basic conversions. So 1080 metres is going to be 1.08 kilometres because there are 1,000 metres in a kilometre, so all we need to do is just divide the metres by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometres at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to 2 decimal places will be 5.40. Whenever you have a one-digit number or a 1 decimal place number, but you're asked to round it to 2 decimal places, you should really put a 0 on the end, which is what we've done.
If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120, and we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So we're given 21 to 4 is the ratio, and we're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay. And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. When something gets to the power of 4, you times it by itself 4 times. So we're going to do that to the x cubed here. So we've got x cubed times x cubed times x cubed times x cubed. Now when two powers of the same base are multiplied together, you add the powers together. So here we're going to add the 3, the 3, the 3 and the 3, and that will give us x to the power of 12. Now there is a simple rule here that we can use. Whenever you've got a power on the inside of a bracket and a power on the outside of the bracket, all you need to do is multiply them together. 3 times 4, which is 12. So I'm going to write the question out. So y equals x plus 15. And we're told that we want to make x the subject to the formula. Now what that means is we want x on its own. What's stopping x from being on its own? This plus 15. So to get rid of it, we do the inverse, the opposite of plus 15 to both sides. Take away 15. So we end up with having y minus 15 on the left hand side, and we've got rid of the plus 15, so we've just got x on the right hand side. So x is equal to y minus 15. So I'm going to write this question out a bit bigger, just so we've got a bit more room. And we're asked to solve. So what we're going to do with this is we're actually going to start by putting our solving lines in. and we're going to try and figure out what we do to get x on its own. So we're going to start by subtracting 9 to both sides, and so that will leave us with the 10x squared on the left hand side and then 250 on the right. Then we're going to divide by 10 both sides, so we've got x squared equals 25, and then we're going to square root both sides. Now this does give us 5, but it also gives us -5, because minus 5 times minus 5 is also 25. So our two solutions are 5 and -5. So angles and a point add up to 360, and we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. To see if a number's in a sequence, we get the nth term and we get it equal to the number we think is in the sequence. And if the number is in the sequence, then we'll get a integer for n. If the number's not in the sequence, then we'll get a decimal. So we're just solving this now, and we're doing 135 take away 24, which is 111. And then we're going to divide both sides by 10, and you're probably already seeing the fact that it doesn't work exactly, because n is 11.1, which means that Prisha is wrong. 135 can't be in that sequence. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising, because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u, and there's just a u on both of them I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph.
So quadratic function.
To find the probability that James will read on both days, we start here and we just draw down the read path, and then we go down the read path again. So the outcome here will give us the probability that James will read and the read. And to work out what the total probability is, well, the first one says read on Saturday, so that would be 11 over 13. The second one is read on Sunday, so that would be 9 over 10. And the word and in probability means times. So we're going to do 11 times 9, which is 99, and 13 times 10, which is 130. So our answer will be 99 over 130. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same. So it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus x and minus x, so that's be a minus x. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know x is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8. And 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. So the question asks us to go from A to C. So we're starting at A, going to C. Now it would be nice if we can go straight there. We don't know the name of that road. So we're going to have to go down this road first, and then up this road. So the first road is road A, so we're going to go down A. And then the second road is road B, so plus B. So in this question we've got a right angle triangle, and it involves two lengths and an angle. So it's going to be a trigonometry question. So we're going to start by labelling the sides. So we've got the hypotenuse opposite the right angle, opposite is opposite the marked angle, and the adjacent is between the right angle and the marked angle. Now notice the opposite doesn't have a number or a letter next to it, so we're going to cross that out, we're not interested in that. And we're next going to draw our triangles for SOHCAHTOA. So it'd be SOHCAHTOA. And we cross out the opposite, so we're not looking at a sine or tan, we're going to be looking at the cos. So it would be cos the angle, or cos x, equals A over h. And the angle is 37, so cos 37 equals 7.1 over x. Now, whenever you're in this situation, and we're just going to put our solving lines in because we're going to be solving this next, if I can press the right button, there we go. And whenever you're in this situation, what you can do is swap
the left hand side, it has to be the whole of the left hand side with the x at the bottom. You can just swap those over, and effectively what we're doing is multiplying both sides by x and then dividing both sides by cos 37. So when we swap those over, we get x equals 7.1 over cos 37. When you type that into your calculator, just make sure you close the bracket. If when you type in cos it opens a bracket, make sure you close the bracket before you ask your calculator for the answer, or press the equals button, and that would be 8.890 blah blah blah. And when you round that to 2 decimal places, it will be 8.89. So there are 3 parts that we need to find the area of. We're going to start with the easiest bit first, this circle at the bottom here. Okay, so the circle area is just going to be pi times r squared, and the radius is given to us at the top, which is 9, so it's just going to be pi times 9 squared, and that would be 254.469 blah blah blah. Or we could leave it as 81 pi. Next bit is the curved bit of the cylinder. So we're going to do the cylinder next. And it's just the curved bit, and the formula for that is 2 pi r h. So 2 times pi times the radius, which is 9, times the height, which is 30. And that will give us 1696.460 blah blah blah. And the last bit is this hemisphere here. And so let's do the hemisphere. And the formula for the area of a hemisphere, well, this full sphere is 4 times pi times r squared, but because it's a hemisphere, it's half of that. And so it'd be half times 4 times pi times the 9 squared, and that will give us 508.938. And so the final thing is to work out the total area, so total surface area. And we're just going to add up all these numbers together. So we add up the 254.469, the 1696.460 blah blah blah, and the 508.938 blah 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 blah. And we get 2459.867 blah blah blah. Do make sure you show the examiner that you're adding these 3 here. I've not done that because it wastes a bit of time for a video, but make sure you write it down. It says it wants it to 2 decimal places, so that will be 2459.87 centimeters squared. So in this question we are told that the centre of enlargement is at 6,4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.